Assalamualaikum and hi. Our group will be presenting about electrocardiogram or also known as ECG. Before I go further with all the explanation and stuff, meet my group mate. In this video contain introduction, explanation of relevant electricity and magnetism concept, detailed exploration of ECG, example of ECG, potential benefit and challenge, and future development and innovation.
So for the introduction, I'm going to tell you guys what is electrocardiogram mean, or most known as EKG. It is a diagnostic test that capture the heart electrical activity over time.
It is frequently used to assess the heart rhythm and electrical conduction. This electrode detects the electrical impulses generated by the heart as it contracts and relaxes. An electrocardiogram or EKG is used to see how the heart is functioning by being positioned on the chest to capture the electrical impulses that cause the heart to beat, and the result will appear on computer monitor as a wave. This electrocardiogram process basically takes about 5 to 10 minutes. Any changes like steady or irregular heartbeat in EKG process can be a sign of many heart-related conditions.
Next, I will explain to you the relevant electricity and magnetism concept. Before we go through the relationship between them, let us know about what is electricity and what is magnetism. So, electricity is a form of energy used to operate electrical machines and appliances, such as lighting for houses, companies, and institutions. It is also used to run electric motors, electrical transformer, network for communications, appliances, and also electronics. This energy will be transmitted through copper conductor wire. The charged particle will flow through the conductor in a particular direction. The source of the electric charge could be an elementary particle, an electron, a proton, an ion, or any larger body that has an imbalance of positive and negative charge. This is because when the charged particle flows through the wires, the electricity will also flow. For example, the flow of water. It is similar as the flow of electricity in a certain direction is called as current electricity or electric current. What is magnetism? Magnetism is a kind of force that can be either repelled or attracted that travels at the speed of light up to a certain distance. A magnetic field is the distance that this force acts, which can be repulsive or attractive force. Magnetic field can induce charged particles to move, which is it producing an electric current. Magnetism is caused by the moving electric charge, especially electrons. So, when there are two magnetic materials are placed close to each other, they will experience an attractive or repulsive force. Any magnetic particle or object has a north and south pole with the direction based on the orientation of the Earth's magnetic field. So, if same poles like north and north, they will repel each other. Meanwhile, if the opposite poles like north and south, it will attract each other. So, how does electricity and magnetism related toward each other? The electric current that flows through the wire will produce a circular magnetic field outside the wire. The direction of the electric current will determine whether the direction of this magnetic field is moving clockwise or counterclockwise. It is similar when an electric current flows through a wire or conductor as the magnetic field changes. The interaction that happens between electricity and magnetism is called as electromagnetism. To demonstrate that an electric current will generate a magnetic field, you can simply place a magnetic compass next to a wire in a circuit. When current is passed through the wire, the compass will deflect, indicate that the presence of a magnetic field circling the wire. This is the experiment which was happened by Professor Hans in 1819 on how magnetic field of a current is discovered. These are some basic concepts of electromagnetism. Firstly, same electric charge will repel and different electric charge will attract each other. The force of attraction or repulsion is inversely proportional to the square of the distance between them. Secondly, magnetic poles will always exist as north-south pairs. It is same as the electric charge, which same poles will repel and different poles will attract. Thirdly, an electric current in a wire will generate a magnetic field around the wire. Just like I have said it before, the direction of the electric current will determine whether the direction of this magnetic field is moving clockwise or counterclockwise. We can use the right hand rule where the direction of the magnetic field follows the finger of your right hand if your thumb is pointing in the current direction. So lastly, moving a loop of wire toward or away from a magnetic field will induce a current in the wire. The direction of current depends on the direction of the movement.
So, let's explore the terminology of electrocardiogram. First, in electrocardiogram, there has lead wire, lamp clamp, earth wire, power cord, print paper, user manual and test electrode. The lamp clamp usually put on lower inner forearm and lower inner legs, or upper inner arm and lower inner thighs, or upper inner arms and lower abdomen. Next, chest electrode. They are usually put the chest electrode in some of part in our body. For the V150, intercostal space at right border of the sternum. For the V24, intercostal space at left border of the sternum. V3 are put midway between position V2 and position V4. For V4, at the mid-clavicular line in the fifth intercostal space. For the V5, at the anterior axillary line on the same horizontal level as V4. For the V6, at the mid-axillary line on the same horizontal level as V4 and V5. Next, let's talk about ECG paper. First, we would define about purpose of ECG. ECG is for to determine the rate, ramp, and abnormalities of the electrical impulse in the heart. First, we need to observing the ECG paper. Notice the small box labeled with numbers and letters corresponding to different areas of the heart. The large line represents time, with each small box typically equal to 0.04 seconds. The baseline is the flat line at the bottom, representing the resting state of the heart. Third, time intervals on ECG paper. Each large line represents 0.1 second and each small lines represent 0.02 second. There are continuing small lines between two large lines help determine the rate of electrical impulse. Then the waveforms. Waveform represent electrical activity in the heart. The general shape is usually tall waveform indicate a strong electrical signal, while flat waveform suggest a weak signal. Then, reading ECG paper. Identify the abnormalities by analyzing waveforms and their characteristics. Lastly, professional interpretation. ECG interpretation requires training and experience. There are always consult a qualified healthcare professional for accurate diagnosis and decision making. For the next, let's talk about another example that have same application with electrocardiogram. First, electromyography (EMG). EMG is commonly used in clinical setting to diagnose and evaluate disorder affecting the muscle and nerve. It helps to identify conditions such as muscular dystrophy, peripheral neuropathy, and myasthenia gravis. For the second is electroencephalography, EEG. EEG is widely used to diagnose and monitor epilepsy by recording the electrical activity of the brain. It helps identify abnormal patterns, seizures, and provide information for treatment decisions. And the last one is electrocorticography, ECOG. ECOG is used in neuroscience research to study neural activity at more localized level compared to EEG. It provides insight into the mechanism underlying various cognitive function and
So here I'll talk about potential benefits of electrocardiogram. First, improved diagnostic accuracy is one of the significant benefits of ECG testing. ECG results are reliable, thus making it easy for doctors and healthcare providers to suggest a detailed treatment plan. ECG testing is also essential in diagnosing coronary artery disease (CAD). It occurs when plaque builds up in the arteries leading to the heart. CAD increases the risk of heart attacks and other cardiovascular events. An ECG can show whether there are any signs of reduced blood flow to your heart muscle and identify areas at risk for ischemia, lack of oxygen, or infarction, tissue death. For individuals who have already been diagnosed with a cardiovascular condition, routine ECG tests can help monitor their progress accurately by comparing previous test results over time. Doctors can assess how well treatments are working and make necessary adjustments.
Next, potential challenge when using an electrocardiogram. Firstly, inaccuracy. So there is one popular technique for Holter ECG examination, which is manual ECG analysis. The result of such analysis mainly depend on the knowledge, skills, and vigilance of the doctor carrying it out. However, some cardiologists and other medical professionals can sometimes lead to unintentional mistakes due to the high level of stress and time pressure. Because of this method is prone to human error and often inaccurate. Secondly, interpretability. Because of deep learning models are often considered as black box models, often consist of several model parameters or complex model structures, it is become challenging for a human to understand why a certain result is produced by such a model. This problem is significantly more serious in the medical field because some medical experts, or I can say all medical experts, will not accept a diagnosis without any explanation. So the last one is data collection. As you can see at the table 2 here, there is no standard in collection procedures. Different research have used various number of leads, durations, and sources, which is subject backgrounds. This makes it challenging to accurately compare results across several databases. Furthermore, it is also challenging to obtain high-quality data and annotations, which is why many recent investigations continues to rely on the MIT BIH arrhythmia database, which was collected over 40 years ago. The most recent single-lead PhYoNet Computing in Cardiology Challenge 2017 and 12-lead 2018 China Physiological Signal Challenge use high-quality data, but they both focus on short-term ECG recordings only.
And here I will talk about future development and innovation of electrocardiogram. First, wearable system. The wearable health monitoring system can be based on a microprocessor and customization platform, smart textiles, body area network, commercial Bluetooth sensor or mobile phone, etc.
However, the variables involved in the performance of this system are usually antagonistic, and therefore the design of usable wearable system in real clinical applications entails a number of challenges that have yet to be addressed, including sensor contact, location, rotation, signal correlation, and patient comfort, and two objective functions including functionality and wearability. Second, ECG automatic analysis. At present, the application of ECG automatic diagnosis technology is not very extensive. It still lacks a complete set of suitable algorithms. Therefore, much research is needed in the field of automatic ECG analysis. Abnormal change in ST morphology is an important indicator of heart disease, especially for myocardial ischemia. An automatic classification of ST morphology provides valuable information for physicians in the diagnosis of myocardial ischemia, especially in long-term and remote ECG monitoring environments. And the last one is hardware. The portable ECG monitor is developing toward a multi-channel new record digital intelligent network sharing device that will use digital technology to improve work efficiency and accelerate timeliness. This will significantly improve the accuracy of clinical diagnosis. The research and development trends of ECG detection and analysis system mainly include the following aspects: a compact instrument and an acquisition synchronization of 12 channels.
To conclude, after all the benefit and fact have been stated, electrocardiogram is important and crucial to assist in identifying the affected area of the heart. As we know, this ECG procedure detects any heart problem more quickly and efficiently. However, misinterpretation of the electrocardiogram can lead to inappropriate clinical decision with adverse outcome.